we're talking about properties, and we want to recognize the properties of equality and identity and recognize the commutative and associative property. So here we have a couple practice. We have 5 examples here to pick from, and we have to decide which one of the properties that we watched in the previous video is the property that we're talking about. So here we have A times B is equal to B times A. So what happens here? We're basically just changing the order of things or flipping them around. So this one is going to be commutative. We look here, we got 3 plus 4 plus 7. And where we switched A and B here, now for this one we're switching the 3 and the 4. So this is also the commutative property. So this is the commutative property of addition. And this one was the commutative property of multiplication. Here we have 2 plus 1 plus 5, where 5 is outside of the parenthesis. And here we have 2 plus 1 plus 5, where 2 is outside of the parenthesis. So this is when we change who the numbers are associating with first. And so this is going to be the associative property. And then what are we doing here? We're adding. So associative property of addition. If we look over here, we have 3 times 5 times 8. And here we have 5 times 8 times 3. So this one, again, we're changing which one we're multiplying first. So this is the associative property of multiplication. And then we have 3 times 1 times 6 and 1 times 3 times 6. In this case, the grouping is the same. We still have the 3 and the 1 and the 1 and the 3 in the parentheses. But what happened was we flipped, or we changed the order of the number in the parentheses. So that's going to be commutative. Commutative property, and in this case we're talking about multiplication. And we look down and we have some other inverse operation practices. So basically this says write the inverse operation. So if we're talking about the inverse of addition, so this is like saying plus 3. So what would be the opposite, or how would we get to 0? So this one we're thinking inverse of addition, how do we get to 0? That's our goal. So if we had positive 3, how would we get to 0? We would have to subtract 3. If we had positive 1/2, how would we get 1/2 to be to 0? This is positive, so we would just subtract 1/2. Positive 2/3, we would subtract 2/3. Negative 3/4, how do we get back to 0? We go with a positive 3/4. And negative 7, how do we get back to 0? We add 7. So that's the addition inverse. Basically, we take whatever, we use the opposite sign with the same value. Multiplication, the inverse of multiplication, we want to think, how do we get to 1? So our goal is to try to make the value at the end become 1. And in this case, we need to know the reciprocal. Which basically just means flip the fraction. So we just want to flip the fraction. So in this case, originally we're given 3, and we can understand that 3 is over top of 1. So if we want to flip that, our reciprocal will be 1/3. So we would multiply by 1/3. Here we have 1/2. The reciprocal of 1/2 means we want to flip our numerator and our denominator. So we have 2 over 1, which is the same as 2. Here we have 2/3, and we want to flip in our numerator and our denominator. So we have 3 over 2. And now we have -3/4. We want to keep the negative sign, but we want to flip our fraction. So we go 4/3. And then -7. Remember, we can say -7, and then we can say that's over top of an understood 1. And so if we flip that fraction, we get -1/7. So if we take a look at this, if we say 3 minus 3, what's that equal to? 0. 1/2 minus 1/2, that's equal to 0. 2/3 minus 2/3, that's equal to 0. -3/4 plus 3/4, that's equal to 0. And -7 plus 7, that's equal to 0. So the inverse of those, this was the inverse by addition. Because we got 0 on the end. Now when we do multiplication, if we did 3 times 1/3, that's equal to 1. If we did 1/2 times 2, that is equal to 1. If we did 2/3 times 3/2, that is equal to 1. If we did -3/4 times -4/3, negative times negative is positive, and then -3/4 times -4/3, that is equal to 1, because the 4's cancel and the 3's cancel. And then if we did -7 times -1/7, negative times negative is positive, and our 7's cancel, so we're just equal to 1 there. So if we're thinking write the inverse operation using addition, we want our answer to be 0 when we get done. If we think write the inverse operation using multiplication, we want 1 to be our answer when we get done.